Hello everybody. Today we are today our topic of discussion is quadratic equations. So let's start. Now we will first discuss what is a quadratic equation. So our equation which is of the form ax squared plus bx plus c equals 0, this is a quadratic equation. I will just take okay. So this equations is a quadratic equation, and the conditions that you will find here okay, and you will see here A, B and C are constant terms. These are the constant terms. Okay, and here X is the variable. Sorry. So here X is the variable. And also note, in this kind of quadratic equations, like in any quadratic equations, A cannot be equal to 0. Okay. Now let's say, why can A, B not be equal to 0? Let's say in our case, let's take a case where A equals 0. Suppose A equals 0. So if A equals 0, we find the equation becomes of the form bx plus c equals 0, right? So if bx plus c equals 0, the first term ax squared, that will become 0, and the equation will become get converted into bx plus c equals 0, which will become a linear equation. This will become a linear equation now. Okay, so let's see what's the exact difference between a quadratic and a linear equation. You see, in a linear equation, the highest power of the variable x is 1. This is the highest power of x is equal to 1. And in a quadratic equation, ax squared plus bx plus c, the highest power of variable x is 2, right? Highest power is 2. Here the highest power is 1. So in a quadratic equation, the highest power of x, which is a variable, will always be 2, and in linear equation it will be 1. And this highest power is also referred as the degree of the equation. This is also referred as the degree of the equation. Now we can find, now suppose it's a cubic equation where we have like 3 terms. Let's say it's a cubic equation where we have 3 terms. It will be ax cubed plus bx squared plus cx plus d equals 0. So this is a cubic equation where the degree of this equation is 3, and the highest power, because the highest power of x is 3, right? So we understood what is a quadratic equation. A equation of the form ax squared plus bx plus c equals 0, where the highest power will be 2, where a, b, c are constant terms, and a can never be equal to 0, because if a is equal to 0, it will get converted into a linear equation. Now let's understand a little bit with a practical example. What is a quadratic equation? Suppose we have a rectangle. Let's say we have a rectangle where the length of the rectangle is, let's say, x feet. Let's say this is x feet. And the breadth of the rectangle, let's say, is 1 feet more than twice the, the breadth of the rectangle is x feet and the length of the rectangle here, let's say, is 1 feet more than twice the breadth of the rectangle, right? So it will be, let's say, 2x plus 1 feet more than the twice the breadth of the rectangle, right? So what will be the area of the rectangle in this case? The area will be x into 2x plus 1, right? It will be, then if we multiply it, 2x squared plus x. Let's say the area is given as 300 feet square. Okay, now this becomes a quadratic equation. You see, 2x squared plus x minus 300 equal to 0. This equation is of the form ax squared plus bx plus c equals 0, where a equal to 2, b equals 1, c equals minus 300. So we discussed a practical example, like where quadratic equation can be used. Here you see this is a quadratic equation. So this is a practical example that we just discussed right now. Now we will go to the next slide. Now we will see what is called roots or solutions of a quadratic equations. Now roots and solutions, let's say we have an equation ax squared like the previous equation. This is a general expression. This is a general equation of quadratic equation. Ax squared plus bx plus c equals 0. The root means for what value of x this expression ax squared plus bx plus c, when it becomes equal to 0, that value of x is called as the root of the equation. That means for x equals to alpha and beta, suppose ax squared plus bx plus c becomes 0, then alpha comma beta are roots of the equation, above equation. Okay, now let's see an example. Let's take an example. Let's understand this concept a little bit with an example. Let's say x squared minus 7x plus 12 equal to 0. Let's take this example. Now we need to find out for what value of, we need to find out the root of this equation x squared minus 7x plus 12 equal to 0. For that, as I already said, we need to see for what value of x this expression on the left hand side becomes equal to the expression on the right hand side, which is x squared minus 7x plus 12 will be equal to 0. For what value of x is it possible? Now let's check with x equals 3. Let's say x equals 3. Let's see if x squared minus 7x plus 12 is equal to 0 or not. Let's check it. X squared minus 7x plus 12, this is expression. Instead of x, we will substitute x by 3 here. So it will be 3 squared minus 7 into 3 plus 12 equals 9 minus 21 plus 12 equals 0. You see, x squared minus 7x plus 12 becomes 0 when x equals 3. Therefore, 3 is a root of the above equation. Right? Now let's say we will take x equals 2. Let's see what happens when we take x equals 2. We will similarly write here x squared minus 7x plus 12. Instead of x equals 3. This time we will substitute x as 2. So we write here 2 square minus 7 into 2 plus 12. What we get, let's see, 4 minus 14 plus 12 is equal to 16 equal minus 14 equals 2. So this is not equal to 0, right? So that here we see the left hand side is not equal to the right hand side. Therefore we conclude 2 is not a root of the above equation. So we conclude here 2 is not the root of the above equation. I guess you guys are understanding this point. What is a root of equation and what is not a root of equation. For a root of equation, the left hand side needs to be equal to the right hand side for that value of x. If it satisfied that condition, then that value of x will be a root of the quadratic equation. Let's go ahead. Now we will solve a quadratic equation by factorization, by method of factorization. Okay. So what do we mean by solving a quadratic equation by factorization? Let's write the previous example. X squared minus 7x plus 12 equals 0. So in the previous slide I showed you that for x equals 3 this expression becomes 0, and then we came to the conclusion that 3 is a root of the above equation, right? But you won't be served on a platter like that, right? You need to find out what will be the root of the equation. You cannot check for every integer. Like let's check for x equals 3, let's check for x equals 4, x equals 5, x equals 6, for which value of x the left hand side will become equal to the right hand side. You cannot check for every other number, right? You need a proper method, proper technique to find out what is the exact root of a quadratic equation. If you just follow that route, if you just follow that method, you will get that answer. You will just understand, you will just know what is the root of that quadratic equation if you just follow that method. So that's what we are trying to establish here. We are trying to solve a quadratic equation. By solve I means we are trying to find the value of x for which this equation holds true, like the LHS will be equal to RHS, and we will do it through the method of factorization. So what is our objective, like how we will find, like how to do it through a method of factorization? Let's see that. So for this method, what we need to do, we want to express this expression as a product of two other expressions which will give a value 0. So this is our objective. We want to divide this x square minus 7x plus 12. We want to express this expression as a product of two other expressions. And then what we will do is, suppose a cross b equals 0. What can we infer if a cross b equals 0? The only thing we can infer from a cross b equals 0 is either a equal to 0 or b equals 0, right? Similarly, that's what we are going to do here. From here, when we express x square minus 7x plus 12 as a product of two other expressions, the only thing we can infer is either this expression will be equal to 0 or this expression will become equal to 0. And when we get this expression equal to 0, we will get a value of x. Similarly, when we equate this expression equals 0, we will get another value of x. So that's how we will solve using quadratic equation. Let's just solve this problem only and let's find out what will be the root of this equation. Now you can follow a technique in finding in factorizing an expression. Let's see. So now we want to factorize this expression. By factorizing we means we want to write it in a product of two other expressions. So first we will write here x squared, and then here is a minus, right? So we will keep the minus here. We'll write in a bracket, keep a bracket, and here is an x. We will keep the x here, and there is a plus. We'll keep the plus here, and 12 plus 12 here. Now this middle expressions we want to write it as some addition or subtraction of two other terms. this middle term, minus 7x, we want to write it as addition or subtraction of two other terms. Now let's see how we will write it. Now you see the operator in front of this constant term 12 is plus, and the operator in front of this squared terms is plus. So now we will need to multiply this plus whatever the operator here and the operator here, we need to multiply them and write it here. So both are plus, so if we multiply it, we get a plus sign, so we write here plus. And also we need to multiply this 12 and this 1, which is the 1 is the constant term for x squared, and let's write here 1 cross 12 equals 12. Now we want to express this 7, which is in the middle term, minus 7x. As you can see, we need to express 7 as sum of two factors of 12. Like 12, what are the factors of 12? 12 can be written as 4 cross 3, 12 can be written as 12 in cross 1, 12 can be written as 2 cross 6. You can write 12 in various ways, right? But you see, only when we add 4 plus 7, we get 4 plus 3, we get it as 7. So we will write here 4 plus 3. Then you see x squared minus 7x plus 12. So if you write 4 plus 3x, then if we multiply with the minus sign, which is just in front of the bracket, we get minus 7x again, and then it's plus 12. So this is how we do factorize. This is a method we use to factorize any expression. So we just discussed this here. This implies x squared minus 4x minus 3x plus 12 equals 0. So from here, what we get, the first two terms, x squared and minus 4x, we take what is a common factor between x squared and minus 4x. X is a common factor, right? X squared has two factors, one is x, another is x, and minus 4x has among few factors, one is 4, another is x. So common factor we get as x, and then we put a bracket. If we multiply x and x, we get x squared, minus, if we multiply x with 4, we get minus 4x. Similarly, we find the common factor between minus 3x and plus 12. We write here minus 3, then we get here x, and we write here minus, and then we get here 4 equals 0. The reason we don't write here plus 3, then we will get here a minus x and a plus 4, but we want these two terms to be equal. Like we want the terms inside this bracket to be equal because of the next step, because we want to take this term again. This term is a factor of this, x minus 4 is a factor of this term x into x minus 4, right? And x minus 4 is again a factor of 3 into x minus 4. So we want to take it out. We want to take it as common, and then we can write is x into x minus 4 will gives us x into x minus 4 again, minus 3, which gives us 3 into x minus 4 again. So we write here as 0. From here, similar to which we discussed, a cross b equals 0. That means a equals 0 or b equals 0. Similarly, here we get as x minus 4 equals 0 or x minus 3 equals 0. From here we get x equals 4 or x equals 3. So we get the roots of a quadratic equation. So these are the roots of the quadratic of the equation. These are the roots of the equation. And also notice, for a quadratic equation you will always get two number of roots. Maybe like, let's discuss it here a little bit. This is x squared minus 7x plus 12 plus 0. If it's a quadratic equation which we will determine by the power, highest power of x, if it's a quadratic equation you always get two roots. Maybe there are some cases where both the roots are equal, but you will get two roots. Maybe, although if both the roots are equal, you can say it's one root, but still we say that as two roots. But for a linear equation, let's say it's ax plus b equals 0, we get here as only one root. Here we get as one root. So here, as I say, if both the roots are equal, then also we say as two roots. It's because we can say it through geometry, but I'm not going into that depth. So it's better right now for the timing, you guys just understand that if both the roots are even equal, we say that we are two roots, because actually we find it why both the roots are equal, we find it through geometry. It's like at the what the graph where it intersects the x-axis. So but I'm not going there in this topic. It's a little advanced at quadratic equations. And also, let's say if it's a cubic equation, ax cubed plus bx squared plus cx plus d equals 0. Here, since the highest power of x is 3, we get 3 roots as a equation, as a solution for this cubic equation. I guess you guys have understood it. Let's proceed. So let's solve an example. So this example we already solved here. So this example, find the roots of a quadratic equation, we already solved here. So I will just skip this slide. So the next slide, it is find the roots of a quadratic equation by factorization, the same method, for 3x squared minus 2 into root over 6x plus 2 equals 0. What I would suggest you guys to do, pause the video, use the same technique that we discussed in the previous slides, the method of factorization, how we factorized an expression, and then turn that first expression into product of two other expressions, and then equated each of the expression to 0, and then found the value of x. I would suggest you guys trying to do that yourself first by pausing the video, and then come here and check what I do here and see if what you do is what I do, so it's fine. Then if it's correct, then that will be good. It's a good learning experience. Okay, so I hope you guys have already paused the video and tried yourself. So now let's see what we will do here. Similar to what we did in the previous problem, we again write here 3x squared, and we write here minus, since here is a minus, we write here minus, bigger bracket, since here is x, we write here x, and plus 2, we write here plus 2 equals 0. So you see the operator in front of the constant term is plus, the operator in front of the squared term is plus, so both the plus when multiplies gives a plus sign, so we write here a plus sign. Also I told you previous slide that we need to multiply this 2 and this 3. So if we multiply this 3 and 2, we get a 6. And now from the factors of 6, we need to add any two factor of 6, which will give the value as 2 root over 6. Let's say 6 can be written as root 6 cross root 6 equals 6, right? So if we write here root 6 and root 6, we get as 2 root over 6. So here we can write here 3x squared minus root over 6x minus root over 6x plus 2 equals 0. From here we can write, let's take here root over 3x as common here. So what we will get, if from the first two terms we take root over 3x as common, so we get another root over 3 into x minus root over 2. That's what we get. From the second two terms we take minus root over 2 in 2 over 2 as common. So we get here root over 3x minus root over 2 equals 0. The reason we took root over 3x and root over 2 common here, we want these terms to be equal. You can do it in various ways, just that it looks good, so we took root over 3x and root over 2. You can take something else also as common outside, because this will anyway become equal if you take the correct factors out. So here we can take again root over 3x minus root over 2 as a common factor and take it out, and we will get here root over 3x minus root over 2 equals 0. Since this gets, we express this expression in the product of two other expressions, so we can write the first term equals 0 or the second term equals 0. So similarly we will write root over 3x minus root over 2 equals 0, or root over 3x minus root over 2 equals 0. From here we will get x equals root over 2 by root over 3, or x equals root over 2 by root over 3. You see, we discussed this before, that although it can be a quadratic equation, both the roots can be equal. You see, we got two roots which are equal here. So this condition you can get, but you will get at least two roots. They can be equal, that's fine. But for quadratic you will get two roots, for linear you will get one root, and for cubic you will get three roots. So that's how it works. So yeah, so I think you got this thing. I think you have understood this problem. So we will move on to the next problem, and I would recommend you do the same thing. Pause the video and attempt it, and then we will again come and discuss the next problem. Let's first move to the next problem. Okay, before we try this problem through the method of factorization, I would like to discuss another method to find the roots of a quadratic equation, and I will discuss it here. This method we will discuss a method which is called solving quadratic equation by formula. We can solve quadratic equation by formula. Let's see what we mean by it. Suppose we write here ax squared plus bx plus c equals 0, where a is not equal to 0. Now we multiply, let's use this color, multiply both sides with 4a. So we will multiply both sides with 4a. So what we get here? We get here 4a square into x square plus 4abx plus 4ac equals 0. Now let's take 4ac to the other side of the equation. So we get here 4a square x square plus 4abx equals minus 4ac. Now let's add plus b square to both sides of the equation, right? We will be adding plus b square to both sides of the equation. So it would get 4a square x square plus 4abx plus b square equals b square minus 4ac. So what we are currently doing is we are finding a formula to find the value of x, where we can use it on any quadratic equation. We can just simply use the formula and get the value of value of the roots of the equation. We can just use that formula. Just one second. Okay, we have like 3 more things to do. Okay, so from here what we will do is, the first term is 4a square x square. Let's write it at 2ax square. Let's write it like this. Then the next term is 4abx. We can write it as 2 into 2ax into b. The third term is b square. We write it as b square equals b square minus 4ac. Now you guys know, I guess, what is the formula of a plus b squared. A plus b squared gives a square plus b square plus 2ab. Right, so we can write here as 2ax plus b squared equals b square minus 4ac. What did we use here? We use this formula. Let's write it as u square plus 2uv plus v square equals u plus v squared. So this is the formula that we used here. U plus v squared equals u squared plus 2uv plus v squared. Even if you just simply multiply this 2ax plus b, again 2ax plus b, you will see you get this 2ax squared plus 2 into 2, you will get this expressions. So that's how it goes. Okay, so now what we will do, we will take a square root on both sides of the equation. So we take a square root and we get 2ax plus b. We take a square root here, we get plus minus b into b square minus 4ac. Now what we will do, we will find what will be the value of x in this equation. We will write here x equals mine, and everything else we will move it to the other side of the equation. B square minus 4ac by 2a. So this is the formula which you need to remember. For any quadratic equation, the value of x will be minus b plus minus b square minus 4ac by 2a. That will be the solution, that you can say that is a solution of the quadratic equation. You can say that is the root of a quadratic equation. Now from this formula we can find two other things. We can see what will be the nature of the solution or the nature of the roots from this expression of x, which is minus b plus minus root over b square minus 4ac by 2a. Let's see what will be the nature of the roots from this expression. Now we call d, let's say we call d, which is short, we actually call as discriminant. We call b square minus 4ac as a discriminant. Right? Now there will be three type of solutions, three type of roots for a quadratic equation. Let's see what are the three type of roots that we will get from a quadratic equation. Let's write here case 1, let's write here case 2, let's write here case 3. So for case 1, this discriminant will be greater than 0. For case 2, this discriminant will be less than 0, and for case 3, this discriminant will be equal to 0. So when this discriminant is greater than 0, what we will get, see the square, it's greater than b, the square terms under the square terms b square minus 4ac, it's under a square root, right? And if that is greater than 0, we will get two rational and real roots, minus b plus minus some number by 2a. So we will get, if d is greater than 0, we will get two real roots. So we can get rational or irrational, that's fine, but we will get at least two real roots. That's the thing, because if you find, if there is a proper square root of b square minus 4ac, then we will get rational roots. If there is no proper square term square root of that expression b square minus 4ac, like root over of 5, then we get two rational roots, right? And also you need to remember rational roots always comes under pair, because let's say we get root over of 5, then you see the operator before it is plus minus. So we will get two roots which are always in pairs, like some will be 2 plus root 5, the other will be 2 minus root 5. But it's fine, we will discuss those later. But at this time you need to just understand, if d is greater than 0, we will get two real roots. That's more than enough for this time being. Let's say d is less than 0. What we will get if d is less than 0? You see, if d is less than 0, then under the square terms, if it, let's say, minus 5, you cannot find square root of minus 5, right? You cannot find square root of minus any number, any negative number. You cannot find the square root. So you won't get two real roots, you will get what is called two complex roots. But for the time being, since we have not discussed what is complex roots, and it's not there in the scope of the syllabus, I will just write not real roots. So we won't get any real number, it's something else, it's complex roots. Let's not go there, but you won't get real roots. And let's say if d equals 0, you see here is a case where we were discussing that two roots can be equal, because if d equals 0, here under the square root b square minus 4ac, if it's 0, then we only get minus b by 2a. Then both the roots are equal. Both roots are equal. So that is what we get from the formula. So this is a formula, is x equals minus b plus minus root over b square minus 4ac by 2a. And then we discussed what is a discriminant. Discriminant is the term which is under the square root b square minus 4ac. And then based on the discriminant b square minus 4ac, we can determine what is the nature of the roots. Let's use another. Okay, so we will find from here, this is what we discussed, the nature. What is this? Wow, but it's fine. It's a little funny. Okay, so we will find nature of roots from this expression b square minus 4ac. From this expression, based on if it's greater than 0, less than 0, or equals 0, we will find what is the nature of the roots. Okay, now let's move on. Based on this concept, we will solve a problem. Now we are going to solve this problem. I would recommend you guys to first try this, pause this video and try this problem, and then you come here and see what we are going to do together. So I guess you guys have already tried this problem on your own. Now let's solve it. So this equation, the approach that we are going to do to solve this problem is, first we are going to convert this equation to the form ax squared plus bx plus c equals 0. After we convert it to the form ax squared plus bx plus c equals 0, we are going to use the formula x equals minus b plus minus root over b square minus 4ac by 2a to get the value of x in this equation, which are the roots of the equation. So first let's add the first two terms. These are fraction terms. Let's add them up. So the denominator is the product of these two numbers, x plus 1 times x plus 2. The numerator of the first numerator will be 1 times x plus 2 plus 2 times x plus 1. I guess you guys know how to add two fractions. Equals 4 by x plus 4, 4 over x plus 4. So the numerator here gives us 3x. If we add them up, simply multiply and add them up, plus 2 plus 2, it gives us 3x plus 4. over x plus 1 times x plus 2 equals 4 over x plus 4. So now if we multiply both sides of the equation by x plus 1 times x plus 2 times x plus 4, what we get is 3x plus 4 times x plus 4 equals 4 times x plus 1 times x plus 2. Now here if we multiply the first two terms, what we get is 3x squared plus 12x plus 4x plus 16 equals 4x squared plus 8x plus 4x plus 8, right? We are just simply adding, we simply multiplied these terms. The left hand expressions we multiplied and the right hand expressions we multiplied. Oops, sorry. Okay, so now here what we get, you see this 12x, 8x plus 4x gives 12x, it gets cancelled from here. Now if we take the 3x squared to the other side, we are left with just 1x squared, and then the 4x which is there on the left hand side, we can take it to the other side and write minus 4x, and the 16 we can take it to other sides and it will come as x squared minus 4x minus 8 equals 0. So here you see this is of the form ax squared plus bx plus c, where a equals 1, b equals minus 4 and c equals minus 8. So from here what we can do, we can simply use the formula x equals minus b plus minus root over b square minus 4ac by 2a. So we can just plug the numbers here of ABC. B is minus 4 plus minus root over of b here is minus 4 square minus 4 into a is 1, c is minus 8 by 2, a is 1. So here we come, what minus of minus 4 is plus 4 plus minus root over 16 plus 32 by 2. What we get here is 4 plus minus root over 48 by 2. So here we get as 2 plus minus, you see 4 divided by 2 is 2. 48 we can write as, let's see here, 48. What are the prime factors of 48? 2, 24, 2, 12, 2, 6, 2, 3, 1, 2, 1, 2. From these two 2's we can get 1, from these two 2's we can get 1, 2. So we can get as 4 root over 3 by 2, which will give 2 plus minus 2 root over 3. So we get two solutions of this equation. One is 2 plus 2 root 3 and the other is 2 minus 2 root 3. So this is the nature of roots of a quadratic equation. So here I already discussed the nature of the roots of the quadratic equations, right? I already told you what will happen when d greater than 0, when d equals 0, and when d less than 0. I already discussed this, right? D is the discriminant. I'm just reinforcing the idea a little bit here again, because next we will solve a problem on the nature of the roots. So here these are discriminant when it's equal 0 and d is less than 0, and as you know, d equals b square minus 4ac, which is inside that bracket. Like x equals minus b, x is the root of the equation, minus b plus minus root over of b square minus 4ac by 2a So this b square minus 4ac is called the discriminant. So this is, and from this discriminant d we can find the nature of the roots. If d greater than 0 we get real roots, if d equals 0 we get 2 equal roots, if d less than 0 we get 2 not real roots, we get complex roots, but let's not go there. Let's understand we don't get any real roots when d less than 0. Okay, let's go to the next problem. So this is a similar problem. Find the values of k so that the equation 3x squared plus kx plus 2 equals 0 has equal roots. So they have said it's equal roots. So you need to find out what is a condition for equal roots. You guys know it, right? I just discussed right now what will be the condition for equal roots. The discriminant needs to be equal to 0. So that's how, there's the first condition they have already given to you. So from there you will get the value of k when you've equated d equals 0. And from there you need to find the roots in each case. I would suggest you the same thing. Pause the video and then solve it, and then come back and see this approach. That will be more helpful than just blindly seeing what I'm doing. It's always good to first try it, and because when you try it you are using your own brain muscles, and that's how you become good in mathematics. And in anything that you do, you need to first try it first. So yeah, please do the same. And yep. Okay, so I guess you guys have already tried this question, so I will just solve it here. It's 3x squared plus kx plus 2 equals 0. Since they have equal roots, since roots are equal, what do we get? We get d equals 0, right? So what is d here? D here is a discriminant, which is b squared minus 4ac. What will be the b square here in this case? B square is k here, right? B is a coefficient of x, so it is k here, minus 4, a is 3 here, c is 2 here, this equals 0. So we get as k square minus 24 equals 0. We get k equals root over plus minus root over 24. So this is what we get, and this means plus minus 2 cross 12, 2 cross root over 3 is k equals plus minus root over 3. Now they have said also find the roots in each case. So I'm just showing you what you need to do here. So one equation you will get as 3x squared plus 2 root over 3x plus 2 equals 0. Another equation you will similarly write it as 3x squared minus 2 root over 3x plus 2 equals 0. So similarly here you will find the value of x for this equation and for x for this equation using the same formula, x equals minus b plus minus root over of b squared minus 4ac by 2a. I guess you guys can solve it right now. I have discussed enough of it, but still I'm just showing you this one expression. I'm just writing this expression. So you write minus 2 root over root 3. The value of b is root 2 root over 3. So similarly here 2 root over 3 square minus 4, a is 3, c is 2, and 2a is 3. So you guys just need to solve it and find the answer here. Similarly, do the same thing here, whatever we did here, and we use the formula of x that we discussed, and we get what will be the roots of this in each case. So you will get here probably 2 roots, you will get here 2 roots, probably different roots, but yes, just find out the roots of the equation in both the cases. You got 2 equations because you got the k value as plus minus 2 root 2. So basically you are getting like 4 roots, or 4 roots or 3 roots, because if 2 roots becomes equal then you will get 3 roots, but if all the 4 roots are different then you get 4 roots. So that's how. So I guess we have discussed quadratic equation. the next quadratic equation slide, at least we have built up the concepts of quadratic equation here. We have discussed, let's summarize a little bit. We will take, it's better to summarize a little bit than just solving these two equations. You guys can do it at home. So what is a quadratic equation? We understood it is a form of equation which is ax squared plus bx plus c equals 0. That kind of equation, which is the degree of the equation when it's 2, that is called a quadratic equation. We discussed if it's a cubic equation, the degree will be 3, as here we discussed is. So, and then we discussed what is the root of a quadratic equation, and we said if a degree of equation is 2, that means for a quadratic equation we always get 2 roots of the equation. Maybe the 2 roots can be equal, but we always get 2 roots of an equation for a quadratic. And then we see how we found a quadratic equation. We found out a quadratic equation. We solved a quadratic equation, that is, we found the roots of a quadratic equation by method of factorization, and this is the one way of finding the roots of a quadratic equation. And also we can find the roots of a quadratic equation by the formula method, which we derived the formula. So here by factorization method we saw that we express that expression x squared minus 7x plus 12 into product of 2 other terms. That's what 2 other expressions. That's what our objective will be. The middle minus 7x and the middle term, we need to write it as sum or difference of 2 other terms, so that we can factorize the entire scenario, entire expressions. So that's how we did factorization. So we already solved this problem. We solved a problem using factorization method, and here we discussed how we can find, we derived the formula method, like what can be the roots of the equation from a general expression ax squared plus bx plus c equals 0. From that general expression we found out what can be the value of x, and then we saw what can be the nature of the roots d, which b square minus 4ac, that is called the discriminant. There can be 3 cases, case 1, case 2, case 3, depending on whether d greater than 0, d less than 0, or d equals 0. We will find out what can be the roots of the quadratic equation. Then we solved a problem here. We find out, we expressed it at ax squared plus bx plus c, and then from there we found out what can be the value of x through that formula. So this is the nature of the roots, and here we have the problem where we found out the value of k first, and then from there we found out what will be the roots of the quadratic equation. So yeah, we are at the end of our presentation. So this is the concept build up which we did here. What are the concepts that are required to solve quadratic problems. So next session we will have another session on quadratic, where we will only solve problems, where word problems we will solve. Like there will be word problems which we will express it into quadratic equation, and then we will solve it. So because we are now equipped with how to solve a quadratic equation, we can solve different kinds of problems, different kinds of scenarios in the world, because we already know if we kind of express them into quadratic equation, we are able to find the value of it, we are able to find the answer. So yeah, so okay, so you guys have a good day. I hope you enjoyed the video. Thank you. Bye.